All right. Do you guys remember the formula for a z-score? Close. X minus mu, not m. Over sigma. X minus mu over sigma. X is the data point. Mu is a mean. And just almost wrote sigma next to it. It's a standard deviation. All right. Anybody want to guess on average how long people use their cell phones before upgrading to a new one? On average. So there's people, who keep their cell phones for too long. And there are some people who get a new cell phone ridiculously often. What did you think the average was?
2 years.
Less.
A year.
It's a year and a half. Anybody guess it right? Before upgrading to a new one, the standard deviation is 0.25 years. A cell phone user is selected at random. Find the probability that he or she will use it for less than 1 year before upgrading. Assume that the variable x is normally distributed. Normally distributed means we're making a bell curve, so I'm going to draw a picture because it will help. I'm going to put, this time, instead of 0 in the middle, because I'm not thinking about z-scores, I'm going to put in that 1.5, which is the average. All right, so less than 1 year, maybe 1 year, let's see, a standard deviation is about 0.25, so maybe 1 year is over here. So this is 1 year, and we want to figure out less than 1 year. So I'm going to shade to the left of that. Less than means to the left. All right, you are going to need your sheets, the A16 sheets that have all of that stuff on there. If it helps you to grab a ruler because it helps line things up for you, go ahead, grab a ruler. We will definitely need it. Okay, if we're doing x minus mu over sigma, what should I type in? Or what should I write up here? What's our data point? 1. So it's going to be 1 minus the mean is 1.5, and then divided by 0.25. Hopefully you can do this one in your head. 1 minus 1.5 is negative 0.5, right? And how many times does 0.25 go into that? 2. So the z-score is negative 2, which if your brain is too tired, you could have easily done that in your calculator and figured it out that way. So it's a z-score of negative 2, which makes sense where I drew it, right? That a z-score of negative 2 would be about over here. So now you're going to look up on your chart. You're going to look up negative 2.0. Do you remember, does your chart read to the left or read to the right? To the left. So negative 2.0. I got 0.0228. Okay. All right, your turn with your partner. Try example 2 together. Draw a picture, whole shebang. Talk to each other, guys. I'm going to do it up here at the same time. Make sure you're talking to each other, guys. Don't just sit blankly next to each other. How are we doing? Anybody need more time? Do you understand this one, Caitlin? Okay. Brennan, you doing okay? Rihanna? You catching up all right? Okay. All right. So let's move on to the back side. All right, what do you think about this one? What is the average amount of time somebody spends at a trip to the supermarket? I'm gonna take one. Anybody want to take a random guess? 45 minutes. No joke. Totally right. Nice job. Okay. So we need to find the probability that somebody shops between 24 and 54 minutes. Okay. All right, let's draw a picture. All right, so let's see, the average is 45 minutes. The standard deviation is 12. So 54 minutes, maybe about here.